The first theorem is the sum of either pair of opposite angles of a cyclic quadrilateral is 180 degree we are to prove. For that, you consider a circle at first and you take a quadrilateral whose vertices are on this circle. So at a quadrilateral তোমালোকে consider করিবা ইয়াতে. So let us consider a quadrilateral this way. So whatever way you consider, it does not matter. The main concept is that we have to consider a quadrilateral whose vertex is on a circle. So it's mean, say it is your A, B, C, D. It's a cyclic quadrilateral. Now, say here center of the circle, it is your O. So let me write here. Here ABCD is a cyclic quadrilateral. Cyclic quadrilateral in a circle with center O. With center O. So this much given to you. To show what? To show angle B plus angle D, opposite angles, equal to 180 degree. Then angle A plus angle C, again you have to show angle A plus angle C equal to 180 degree. Means opposite angles are supplementary. For this, one construction is there. So you have to write the construction part. You have to remember the construction. Construction is that join OB and leave C. Then you join O with D. Yani O with B and O with D. This way you have to join. You don't join O with C. Then what's the benefit? You see, as you know, angle at the center twice the angle on the circumference subtended by the same arc. Now if you consider this arc BCD, this arc BCD, or you can say chord BD also. So if you consider this arc subtend an angle at the center and same arc subtend another angle on the circumference. So let me write the construction here. OB and OD are drawn. This is your construction part. Now we are going to prove it. The proof part comes now. It is your proof. So simple, whenever you have to prove some theorem in geometry, first of all, what are given, you write what to show. If there is some construction, write the construction and then you come to the proof part. The proof part using the earlier theorem that is known to you, and I explained it also, that angle at the center twice the angle on the circumference. So now you see here the arc BCD, this side, A arc to Saba, BCD arc के center BOD angle subtend করেছে. What I told, that BCD arc subtends an angle at the center, that is BOD, and the same arc subtend another angle on the circumference, that is your BAD. So you can say this angle is half of the angle at the center. So as angle at the center is twice the angle on the circumference, twice the angle on the circumference. So from here what you can say, angle A is equals to half of angle BOC. So you can write subtended by same arc subtended by same arc BCD. This is the symbol of arc. So here also you can write as angle at the center is twice the angle on the circumference subtended by same arc. That condition is required here. So here that's why angle is half of angle BOD, half of angle, sorry not C, it is BOD, because these two angles subtended by the same arc BCD. Now you see, now let me write in this side. Again, same theorem or same logic you are going to apply. This time, you will apply, suppose if you consider these arc, the greater arc, this arc, if you consider this arc, that is your BAD, and you are observing from this side now. So this arc, subtend angle at the center, this is your BOD. This is your reflex angle BOD. And this same arc subtend another angle at the circumference C. Again, reflex angle BOD. So this is your obtuse angle BOD, and this is your reflex angle. This is your reflex angle. We are talking about this angle. So it better to write this way. Angle A is half of reflex angle BOD. That is from this side. If you observe, so this is angle at the center, this is angle on the circumference. So this is your, sorry, this is not A, this is your C. This is your angle C, half of this angle, or you can say this angle twice of angle C. Now this is your number 1 and this is your number 2. Just you take the sum of 1 and 2. 1 plus 2 implies. So left hand side plus left hand side, angle A plus angle C equal to half of angle BOD plus half of reflex angle BOD. Don't get confused, this is BOD two times. One BOD angle is this side and another BOD angle is from this side, which is your reflex angle. Now see, sum of these two angles, this BOD and this BOD, this is your whole angle or complete angle. Half of angle BOD plus half of reflex angle BOD, here half common, and within brackets angle BOD plus reflex angle BOD. Now you see here, angle BOD, this is angle BOD, reflex angle BOD is this much. Total angle is what? Angle at a point, that's your whole angle, which is your 360 degrees. So that's equal to half of 360 degree, which is equal to 180 degree. So you prove it, then angle A plus angle C is your 180 degree. So similarly we can show angle B plus angle D will be your 180 degree. I mean to say B and D are also supplementary. And for that you have to take these two. And if you join this, say this is your center. If AO and your OC, then similarly it is X, it is Y. Then from this side you can prove it. Then ABC are subtend angle X and FD. So D is your half of angle X. Again from this arc, from this side if you say, then angle B half of angle Y. And if you take the sum, then you will get that B and D are also supplementary. So you can simply write similarly angle B plus angle D equal to 180 degree. Thus opposite angles in a quadrilateral, cyclic quadrilateral are supplementary, we proved it. But in your exam you have to write all the steps in a systematic way. So I have written already what are given, it's written, what construction you have written, and proof part which theorem you are going to use, that's I have written here. So I hope the theorem proof is clear.